And now for a thorough discussion of zero-dimensional space. A dimension is a degree of freedom in which one might travel. Birds fly about with 3 degrees of freedom in the air. They go up and down, they go forward and backward, they go left and right. A dog runs around with 2 degrees of freedom on the ground. All the same degrees of freedom that the bird has, except the ability to fly up in the air. A fish in a river has 1 degree of freedom. I'm basically saying that a salmon has 2 choices at the end of its life. It can keep going upstream, or it can turn around and go back downstream. It can go forward and backward, but that's pretty much it. And a stone has 0 degrees of freedom. A stone just sits there. Locations on a plane can be described with a pair of numbers. Locations on a line can be described with a single number. And it takes no numbers at all to describe the location of a large rock in the yard. In fact, a large rock in the yard is sort of a location. Hey, have you seen my phone? Yes, I buried it under the rock in the backyard. Oh, thanks for telling me. That sort of thing. A zero-dimensional space is a single point. Punk. There you go. In fact, that's a bit bigger than an actual point, but we draw them bigger so that you can actually see them. If there was a very evil dot living there, some sort of hideous zero-dimensional creature, no prison would be necessary, for there is no place for the dot to go, no direction in which to travel. This evil dot can only do evil to itself. There is no other points in the entire universe. There's, evil dots. Not so evil. Well, they might be very evil. You'd have to go there to encounter it. It takes only a single speck of a dot to fill up the entire space, so we call a single dot a solid zero-dimensional box. Ta-da! To have an empty container in 0 dimensions, we need to leave a space for one of those specks. Now we could depict this with no dot at all, but this would be a bit confusing, for it's hard to say where exactly is the lack of the dot. For example, look below. Where exactly is the zero-dimensional space that has no dot in it? That's hard to say. So, thus, mathematicians depict the absence of a point with a tiny circle, indicating where the dot would be if there were one. Punk, like that. That is what we will call a hollow zero-dimensional box or an empty zero-dimensional box. Now, whether it's a box or a circle or a bottle or a jug doesn't really matter. It's just the absence of a single point in a zero-dimensional space. Now, this sort of concept of filled-in circle, empty circle, is most often used when graphing points on a number line. For example, suppose your friend said, hey, you can stop by anytime after 3 p.m., but no later than 4. The graph of all acceptable times to stop by would be graphed as this. There's a number line, bang, there's the graph of all acceptable times. Now, this little hollow circle there indicates that precisely 3 p.m. is not a good time to come. You were told to come sometime after 3 p.m. 3 o'clock and 1 nanosecond, totally acceptable. But 3 o'clock on the nose, I told you not to come at that point. And the solid filled-in circle at 4 p.m. implies that precisely 4 p.m. is an alright time to visit. In fact, the very last possible moment acceptable for a visit. This, however, leads us to one-dimensional spaces because we're working with a line. That's the next video.